Hi everyone! Welcome back to Info 3370, studying social inequality with data science. In the last class, we introduced economic mobility as a prediction problem. Today, we're going to turn into a particular example of that prediction problem, which I'm calling the PSID Income Prediction Challenge. So by the end of class, you'll be able to conceptualize economic mobility in a machine learning framework, and particularly a specific one that you're going to get to engage in where you build predictive models and see how well you perform. Last class, we talked a bit about generalizing economic mobility, where we might have a predictor, parent income, and an outcome, the incomes that children born to those parents realize when they grow up and become adults. We talked about a world of equal opportunity, where knowing one's parents' income tells me nothing about the expected outcome for the kid, and a world of perfect intergenerational reproduction, where knowing the parents' income allows me to perfectly predict the outcome the kid would realize as an adult. Thus, we proposed that there's a lack of opportunity if you can predict a child's outcome given information about their parents. This leads to the question, why stop at income? After all, we might think there are many variables that could summarize aspects of the parents or the childhood environment that might affect a kid's life chances. You could think about the parents' education, you could think about things about the neighborhood, perhaps there are connections with the grandparents and other extended kin. Broadly, there are many variables we could think of as part of this process that we consider economic mobility and opportunity that's driven by the luck of the circumstances you happen to be born into. So we could think a little about what other variables capture the luck of birth. For our exercise, I've already pre-selected a few variables. So I've selected the incomes of parents and grandparents. We've selected race, the child's sex, and then measures of education for the grandparents, the parents, and the respondent. So most of these variables refer to things that are outside of one's control completely. They're just aspects of your family background that relate to the luck of birth. One variable here is the respondent's education, and I've included that as a special variable because ultimately we're going to ask some questions about how the relationship between the other family background variables might differ for those who attain a college degree and those who don't. For now, we're just going to treat all the variables as the same and think about how they predict respondents' incomes. You're going to have access to these data, and your task is to learn a prediction function to predict the respondents' incomes. And you could use any prediction function you want. We'll start out with an example using ordinary least squares, and then we'll turn to some machine learning strategies like generalized additive models and random forests. And the task here is not simply to learn the mapping between predictors and outcomes in the cases we've observed. The task is really to take some new cases and predict the outcomes for those new cases. This is a standard machine learning strategy where we might have many different prediction functions, and we don't know which one is the best. And a way to evaluate which one is the best is to see which one predicts the best when handed new cases. We'll talk about the top set as the learning set. This is the set of cases in which we'll learn the prediction function. Or if you're more classically statistically inclined, you'd say estimate the prediction function. Then we'll talk about the holdout set. And the holdout set is the new cases for which you'll make predictions. And as we go through this exercise, you will not have access to the actual outcomes for the holdout cases. We'll save those for the end, and then we'll score and we'll see who comes up with the best predictive model and what their model was. So the task here is how well can you predict respondent incomes? Will you have the best predictions in the class? We're going to see. To get started, you can go to the course website, which has a web page with this class exercise. And a first step is to get access to the data. So if you go to the exercise page on Open ICPSR, then you'll see that there's some information here. So in order to download the data, you're going to have to create an account and agree to some terms. Then ultimately you'll download the files in forstudents.zip. And these files contain the background variables to be used for prediction and also the holdout set for which we'll be making those predictions. And that's pretty much it. This page introduces the task, tells you a little bit about how the variables are defined. In the data, G1 are variables that refer to grandparents, G2 refer to parents, and G3 refer to the respondents for whom we're predicting incomes. And in the videos to come, we're going to talk about an example submission, a key machine learning strategy of sample splitting, and then 3 specific machine learning estimators that you might use when you make your predictions. So that's the plan going forward. I think it's going to be a lot of fun.